While I was away in Mexico this time, they were running a job for me on my horizontal mill, and one of the cutters got damaged, probably due to not indexing the inserts, I would suspect. And here's the damaged cutter. The inserts failed on the inside edge of the cutter and of course destroyed the tool. So this job starts with a piece of 4-inch diameter 4340 commercial heat treat material. I think that would make it about 34 to 38 Rockwell C hardness. I found this material to be really good to make these cutters out of. It's got excellent toughness and it's not too difficult to machine in the heat treated state. Here I'm just indicating the bar in. I stick the bar out far enough to make two parts, parting them off, and then I have to slide the bar out again to make 2 more parts. You can see the stock's not very round, but it really doesn't matter because I'm taking it down to about 3.5 inches in diameter for the cutter. Here I'm just setting the Z0 for the first part, and I set it out so that I leave 30 thousandths stock to face off for the first part. This is just the procedure for setting it on the Mazak here. So we come in here with the first tool, a roughing tool, and check the insert to make sure it's alright. Then rough off the OD. Down to the, I think it's 2 1/8 inches where it actually mounts on the shell mill shank. So 1-inch shell mill shank that these tools mount on. So this tool just roughs it down straight like that, and then come in with a VBMT insert and rough the undercutted area. This tool needs this for clearance on the part here to bring it down to a smaller diameter below the shank. We got a spot drill. Here's a picture of the parts in the upper right hand corner of the video showing the parts that this tool actually roughs out. Here's a Guring drill that I'm using to drill a hole for the screw. I found that these Guring drills are the best. I've tried various different kinds of these indexable tip drills, and they seem to be working the best for me anyway. A 1/2-inch end mill here to rough out the counter bore for the pilot on the 1-inch shell mill shank. Come back with a finish the OD with the same tool that I roughed the undercut with. We come in with the finishing boring bar to finish the ID. I'm trying to hold this pretty close, within, less than 1/2 thousandth of an inch. So I usually set it down to begin with and then measure it. And this particular part required 8 thousandths more on the bore, so I set it out 8 thousandths in the offset and rerun the tool, and then measured again with the dial bore gauge. In order to get sort of a decent finish on this material, you got to take a fairly deep finish cut. So I usually set it down about 10 thousandths of an inch and then measure it and then set it out to my finish size. This is just milling the key slots for the shell mill shank. This size shank takes a 3/8 key, I believe. So that's that, and then we come in here with a parting tool. This is the style of parting tool. It's an Iskar parting tool, and I didn't have any trouble parting these off. This tool cuts really nicely. So that's the finished part on the first operation. And we have to put a counter bore for the head of the screw and mill the flutes and the insert pockets in the next operations. Here I am just trying it on the fixture that I use to actually do the final operation of milling the insert pockets. So now we'll have some extra cutters in case one gets damaged. I had some, but I ran out of them, and so now I have to make some more.